Alright team, we have got a problem. A leak has developed at the bottom of the ethanol reactor. Flow rate data shows the leak is increasing by 50 ml per second every 20 seconds. We need to assess the situation quickly. If the flow rate increases too fast, it could lead to an explosion. Let's get to work.
Here's what we know so far. At t equal to 0, the flow rate is 0. After 20 seconds, it's 50 ml per second. By 40 seconds, it's 100 ml per second and so on. It's linear increase.
Wait, does that mean that the flow rate equation is something like Qt equals to 2.5t?
Exactly, and the rate of change of the flow rate dq over dt is a constant of 2.5 ml per second squared. This constant is fixed in dq over dt in constant rate. If the flow rate continues, it could hit a candle vapor curve. We need to determine how quickly the ethanol level is dropping in the tank. What's the tank initial value?
The reactor initially had 1000 ml of ethanol. Can we calculate how long it will take for the reactor to empty?
Let's see on how we're going to solve our problem. So first, we are going to calculate for the mass balance for the ethanol in the reactor. Okay, the rate of ethanol loss is equal to Qt, where Qt is equal to 2.5t. If V0 is initial volume of ethanol in reactor, then Vt is the remaining ethanol volume. So, Vt is equal to V0 minus integration of Qt dt, which is equal to V0 minus integration of 2.5t dt, which is equal to V0 minus 1.25t squared. Next, we are going to calculate for the explosion risk. An explosion might occur if the ethanol level reaches a critical volume, V critical. So we are going to set V critical is equal to Vt. So Vt is previously that we have calculated will be V0 minus 1.25t squared, which is now going to be equal to V critical. So next we are going to rearrange our equation. So now our equation will be t squared equals to V0 minus V critical over 1.25. So next we are going to take the square root from the t. So t is equal to V0 square root of V0 minus V critical over 1.25. This gives the time t when the ethanol volume reaches the critical level. After that, we are going to look for the numerical example. Let's say our V0 is equal to 1000 milliliter and our V critical is 250 milliliter. So we're going to take the equation that we have previously calculated from the explosion risk, which is T is equal to square root of V0 minus V critical over 1.25, and we're going to replace the V0 and V critical with the number. So we're going to calculate as T is equal to square root of 1000 minus 250 over 1.25. We're going to get square root of 750 over 1.25, which is equal to square root of 600, roughly equal to 24.5 seconds. So at t equal to 24.5 seconds, the ethanol reaches critical volume. Safety measures must be enacted before this time.
The leak of ethanol from the reactor is very dangerous since it can affect the environment and also human health. Firstly, it can cause explosion because ethanol is a highly flammable substance. So when leak happens, it can create fire hazards, especially if the vapor mixes with air and ignition source is present. Secondly, it can lead to air pollution as ethanol is volatile. When the ethanol evaporates, this will cause human health effects, such as direct contact with ethanol can irritate the skin and eyes, and also ingestion or inhalation can lead to alcohol poisoning in severe cases. Thirdly, ethanol it can also harm aquatic life because if the ethanol leaks into water, the pH of the water changes. When ethanol leaks into water, microorganism breaks it down. This process produces organic acids such as acetic acid. This makes the pH of the water become acidic as the pH is lowered. This pH is not suitable for aquatic life to live in. And lastly, the leak from the reactor can also lead to soil contamination. Acidic conditions may reduce the availability of essential nutrients such as phosphorus, potassium, and calcium, and increase the solubility of toxic metals like aluminium. This will make the soil become unfertile. These are some of the effects of the leakage of ethanol from my research. What are some of the steps that we can take to minimize the danger?
The safety measures is the first, when the area to avoid ethanol vapor build up. The second is initiate emergency repairs to seal the leak. The last one is keeping monitoring the flow rate closely to ensure to unexpected changes. The conclusion is using mathematics, we modulate the flow rate and determine the time to reach a critical ethanol level. Further, safety assessment may involve detailed reactor and process simulation to manage risk effectively.